So when you talk of some common type of cells, what happens is, listen carefully. In this, first we are talking about dry cell. Dry cell is also called as modified Leclanché cell. Modified Leclanché cell. Remember that it is a modified. What is the modification? The difference is that in Leclanché cell, all these electrolytes are in the form of what do you call in the form of solution. Here it is in the form of paste. That is the only difference. Now, what does a dry cell consist of? See, a dry cell consists of a zinc pot. So, dry cell consists of a zinc pot, okay, inside which we have zinc chloride. So you can see zinc metal in contact with zinc ion. Zinc metal in contact with zinc ion, what happens? That is an electrode. Okay. Now, at the center, we have a graphite rod. At the center, you can see we have a graphite rod. At the center we have a graphite rod. Now, the graphite rod is surrounded by a cloth bag. The graphite rod is surrounded by a cloth bag. So, dry cell does not have a tube, direct connection. So, it consists of a cloth bag. And what is there inside the cloth bag? Inside the cloth bag, we have ammonium chloride, manganese dioxide, sawdust, and graphite powder. Okay. Then what happens? This, what do you call? This graphite rod is basically, what do you call? The tip of the graphite rod is, we place a copper cap, a brass cap or a copper cap. Mainly it's a brass cap. And then what happens is, this whole thing, so you can see, this was zinc chloride. So the difference will make you understand treated. And this is then closed with the help of cardboard and sealed with pitch. Now let us look at one by one the reaction. Cell reaction is anode. So anode is an electrode where oxidation takes place. Anode is an electrode where oxidation takes place, and what happens? Zinc forms zinc plus 2 electrons. Zinc forms zinc plus 2 electrons. Is this clear? So what happens is that this zinc pot will have what? The negative charge. Zinc will have negative charge. Then what happens at the cathode? Cathode is reduction. Cathode is an electrode where reduction takes place. Is this clear? So what happens at the cathode is, now which is the species which is going to undergo reduction? This is a CET question or entrance exam question. When I say CET, sometimes remember it's entrance exam question. Because I come from a generation where it started as CET, then it became NEET, new acronyms came, you know. Originally, 20 years back, it was only CET, common entrance test. So, cathode is reduction. What happens? Which is the species which is going to undergo reduction? It is ammonium chloride. So, it's ammonium ion. So, ammonium ion undergoes reduction to form ammonia NH3 plus H2 gas. Now, because of the H2 gas, what happens is H2 gas formed cause polarization. H2 gas formed causes polarization. H2 gas formed causes polarization. Is this point clear? What is polarization? Accumulation of a gas on the electrode, and so further ammonium ion cannot take the electron from the graphite rod. Are you understanding? So the cell will stop functioning. So when the cell stops functioning, what we do is, in order to prevent the cell from functioning, we add manganese down. So this is your entrance exam question. In a dry cell, there is a slight difference between alkaline cell and dry cell. I am talking about dry cell. In a normal dry cell, alkaline battery will come next. In a normal dry cell, what is the role of manganese dioxide? Manganese dioxide acts as a depolarizer. That means continuously it is reacting with the hydrogen, forms Mn2O3 and H2O. This is manganese sesquioxide oxide. It is manganese sesquioxide oxide. Are you understanding? And this water formed is very important because it helps in the in dissolving the ammonium chloride and causing it to ionize. Now you will ask me, sir, what happens if there is too much of water formed? If there is too much of water formed, that's why we have added sawdust. Sawdust will absorb the excess of water. So technically, it's not an absolutely dry cell. It's a paste we are using. Is this point clear? Now, what is a problem that we can have? Now, why is a dry cell? See, we have two types. Dry cell is what? Dry cell is a primary cell. What do you mean by a primary cell? Primary cell means it's simply, what do you call? It simply generates electricity from chemicals. What is a secondary cell? It's a storage cell. It is a storage cell. It is clear. So when I'm talking about primary cell, why it cannot be recharged? That is the question. That's a question, MCQ, that they can ask. So dry cell cannot be recharged dry cell cannot be recharged because what happens? The zinc plus 2 reacts with NH3 and forms, what does it form? It forms a coordination complex ZnNH32, it is clear, plus 2. Now this coordination complex cannot be broken. So what is happening? Zinc is not free again to get reduced back to zinc metal. The zinc gets coordinately complexed with the ammonia formed. So therefore, this dry cell cannot be recharged again. There is one modification. One more thing, what happens is, the ammonium chloride, the disadvantage of this, ammonium chloride is a salt of weak base strong acid. With little water, it undergoes hydrolysis, creates acidic condition. It slowly, what you call, corrodes the zinc and the whole thing can leak. So if you keep the battery for a long time, you'll see that it has leaked because of this. So therefore, one modification is an alkaline dry cell. It's an alkaline dry cell. When you talk of an alkaline dry cell, what is an alkaline dry cell? We eliminate ammonium chloride. We eliminate ammonium chloride. So what have we done? At the anode, you have zinc forming zinc plus 2 electrons. But at the cathode, what happens is you have the manganese dioxide. See, it's something like this. Zinc, you have NaOH, na? Along with zinc solid plus 2OH minus aqueous forms ZNO. So instead of zinc oxide is formed plus H2O plus 2 electron. And here in dry cell it was ammonium chloride which was undergoing reduction. Here it is the manganese dioxide which undergoes reduction now. 2MnO2 plus H2O forms Mn2O3 again plus 2OH minus. This is getting regenerated. So your net reaction is what? Zn plus 2MnO2 forms ZnO plus Mn2O3. So this is how the reaction takes place. So in this reaction, we avoid ammonium chloride. So when we avoid ammonium chloride, the corrosion of the zinc pot is prevented, and of course the longevity is there. In both the case, the EMF of the cell is 5 volt. EMF of cell is 1.5 volt. So remember, whenever you are discussing any cell, you have to conclude that short note by writing the EMF of the cell. There is always a mark allotted for this. Okay, so this was about dry cell. Dry cell. Secondary cell is a storage cell. Secondary cell is a storage cell. Is this clear? That means what does it do? It draws electric current, converts it into chemical energy, stores it as chemical energy, and at a suitable time what does it do? It gives back electrical energy. It gives back electrical energy. Is this point clear? The example of a storage cell is lead accumulator. So the construction of lead accumulator is you have a rubber pot, okay, and then you have a lead plate. So this will be a lead plate. I'll show you the lead plate like last time, what I did last time. And then the next one will be a lead mesh. I hope you understand what a mesh is. Mesh is, so this will be a lead mesh. Wait a minute. So this will be a lead mesh in which we have filled lead oxide, in which we have filled lead oxide. So this together is called as one plate. This together is called as one plate. Now what happens? We have one more plate. So once again, this is lead. Then this is a lead mesh. And inside the mesh, what happens? We fill with lead oxide, PbO. So obviously we're going to connect this in. So this is your negative and this is your positive. This whole thing is kept dipped. This is kept, all these plates are kept dipped. In sulfuric acid, okay, which has a specific gravity, of 1.21, which has a specific gravity of 1.21. So this is, let me complete, this is pure lead, this is lead mesh in which we have put lead oxide, PbO2. Okay, before I continue, I'll show you how this lead and lead oxide looks like. So you have a fairly good idea what we are talking. So you can see over here, that's great. This is lead. The gray color clearly shows you it is lead. And then you can see this is far more. So can you see the grid lines in between? That's the mesh. So lead mesh in which here we have put lead oxide. And what happens is now normally between the negative and the positive we have a polypropylene plate, which we don't show in the textbook and diagram, but generally we put it because otherwise there will be short circuit inside. Na? So this is how it looks. So you have a negative and you have a positive, and this is between, of course there is a, in between this is the polypropylene plate, so to prevent short circuit this is kept in sulfuric acid. I hope now you have got a fairly good idea of what I am talking. Okay. Now let us, the situation that we are in now, this is due for discharge. So what happens during discharge? So what happens during discharge is clear? Give me a minute. So during, talking about what happens during discharge. So this is how the secondary cell is. The way it is arranged, it is ready for discharge. That means now chemical energy is going to get converted into electrical energy. So what do we have? 2H2SO4 forms 4H plus plus 2SO4 minus 2. Now at the negative electrode, see we never say oxidation reduction over here. We always say negative and positive only in this case, in the case of secondary cell, because whether it is charging or discharging, negative remains negative and positive remains positive. Maybe the reactions are opposite, but the charges remain the same. So we have at negative electrode, what happens is, listen carefully, we have lead, Pb. Pb undergoes oxidation to form Pb plus 2 electron. It forms Pb plus 2 electron. But then what happens? This lead ion Pb plus 2 immediately reacts with sulfate to form lead sulfate. So your lead, which I just now showed, the lead gets coated with a layer of lead sulfate. So your net reaction is, we have Pb plus SO4 minus 2 forms PbSO4 plus 2 electron. So because of the release of 2 electron, it is negative during discharge. Then what happens at the positive electron? At positive electrode, what is going to happen? You have PbO2. That was what is there. You had a lead mesh which was impregnated with lead oxide. Why? Because it's a powder, right? Something has to hold it. That's why we had a lead mesh. Okay. So PbO2 plus 4H plus what do we have? One more sulfate ion, because one got used over here. So what will happen? You will get PbSO4 plus H2O plus, that's it. Of course here the reduction, so there are 2 electrons taken. PbSO4 plus 2H2O. Now because of the consumption of sulfuric acid, the specific gravity of the sulfuric acid falls down to 1.18. 1.21 to 1.18. When the specific gravity falls from 1.21 to 1.18, what is going to happen? We say the cell is discharged. That means it's not going to give any electricity anymore. You have to charge. That's the meaning of a secondary cell. It's a storage cell. You can charge it. Is this point clear? So during charging, what is the reaction? So in the exam, they ask this question: what is the reaction of charging? What is reaction due to discharge? Or 3-mark question, they can ask both. So you have to be mentally prepared for both. So what is going to happen during charging? So during charging, you still have some sulfuric acid. H2SO4 forms 2H plus SO. It's not absolutely water, because I told you specific gravity is still 1.18. That means some amount of what you call sulfuric acid is there. Now what you have to do? See, the lead lost the electron and became lead sulfate. So now you have to give electron. So when you have to give electron, while charging, you have to put this in the negative of the what you call main supply, because it's going to come from the electrical mains. So that's why during charging and discharging it is negative only. During discharging it is negative because giving electron. During charging it is negative because it's been plugged into the negative so that electrons can flow in and reduction will take place. So what is going to happen at negative electrode again? At negative electrode, what is going to happen? Exact reverse of this. You have PbSO4 plus 2 electrons plus 2H plus is going to form lead plus H2SO4. So this H plus ion came from here. At positive electrode, At positive electrode, what is going to happen? You have exact reverse of this. The exact reverse of this. You have PbO2, sorry, PbSO4. PbSO4 plus 2H2O. What is it going to form? It's going to form PbO2 plus 2H2SO4 plus 2 electron. Where is the sulfate going to come from? Here. Plus SO4 minus 2. So again, what happens? Again, your specific gravity reaches 1.21. The moment it reaches 1.21, we stop charging. Now that gives rise to a question in the entrance exam. Why the lead accumulator is not charged beyond specific gravity 1.21? Why it is not charged beyond specific gravity 1.21? So what happens is, lead accumulator is not charged beyond specific gravity 1.21 because beyond this electrolysis of sulfuric acid will take place. You're charging, you're giving external EMF. Are you understanding? So I discussed the first topic, electrolysis of different substances. Electrolysis of disulfuric acid will take place giving hydrogen at cathode and oxygen at anode. So that's why even at home when we are using a inverter, you should not keep the battery, everything in some closed this thing and keep it packed and all that. Sure shot recipe for major accident. Always the battery is kept in an open space to allow the hydrogen and oxygen, if at all it is formed, to escape. Because we know hydrogen is explosive. There have been accidents in Mumbai. Now the incidence of using inverter itself is less because power is steady, but few years back we had a lot of problem. Accidents have happened and the blast can be so severe that the ceiling can rip off. That is how serious the blast can be. So that is why all these lead accumulators should be kept in open to allow escape of gases. Is this part clear? Then what else can we say? What is the EMF produced by one plate? So this is one plate, correct? So one plate, the EMF produced in one plate is about 1.8 volt. So you see, if you want 12 volt, car battery is about 12 volt, nearly about 6 plates or 7 plates we put together to get car battery 12 volt. For a lorry, the plates will be very high, the numbers will be. So is it something like this? I'll give you an idea. Suppose I want, each is, if normally we use this inverter, okay, we have a 5 kilowatt, 5 kVA inverter in our office, okay. So when we have 5 kilowatt inverter, the calculation is we require 8 12 watt battery. So that 8 12 volt battery is 5 kilowatt. So that's how we calculate. It's 8 into 12, that is 8 on 8 is 16, 8 on 56, see 56 kilowatt, it is 56 approximately, that is 5 kilowatt. So 5 kVA, this kilo, that's the specification we need. So then we need 8 of these. So 9 volt DC, 9 into 8 is 64, 7 is 56 volt DC. That is the calculation. Okay, you will We'll have to know these things in life. So, this is how we are using the lead accumulator. Now, after lead accumulator, we have normally nowadays, we have this nickel cadmium battery. So, we have to study two more of this. One is nickel cadmium battery and the other is fuel cell. Hopefully, in years to come, fuel cell will become one of the most important storage batteries. So, what can we say about nickel cadmium battery? That's also a storage cell, but for smaller item, like for example, our watches and all that, we have a nickel cadmium battery. So what happens in nickel cadmium battery is, you have cadmium first, okay? Cadmium undergoes oxidation. So what are the points that we have to know? This is little a. So we have at the anode cadmium. So cadmium undergoes oxidation to form cadmium plus 2 electrons. At the cathode what happens? We have nickel oxide NiO2 plus 2 electron plus 2H2. So what does it form? It forms nickel hydroxide. So this is exactly reversible. These nickel cadmium batteries, what happens? The moment you apply the external EMF, this can get. So this is about, not much is there about nickel cadmium battery, but a lot of things is written about fuel cell. So what is a fuel cell? So how is a fuel cell constructed? It consists of a vessel, something like this. Okay. Now this is divided into 3 compartments by using graphite partition impregnated with platinum. So that's where the cost goes up. Fuel cell is costly because of the ingredient that goes into it. This is clear. So it consists of 3 partitions. 2 partition and 3 parts. So this is, okay. So what are these? These are graphite. These are graphite with platinum. Graphite with platinum powder. This is then sealed, and in the center what we have? Hot potassium hydroxide. In the center we have hot potassium hydroxide. Is this clear? So here this is hydrogen inlet. And excess hydrogen will come from here. So this is hydrogen outlet. So this is oxygen inlet. And excess oxygen will come outlet. Of course, it will again sent from here. So this will be your anode and this will be your cathode. So what happens at the anode is, you have, see, you have basically KOH existing as K plus plus OH minus. Okay, that's the first thing. Now in the inside, so here from here, the OH minus is permeating into the porous. This is porous graphite. That's also, I forgot the word porous. It's a porous graphite with platinum. So platinum facilitates the reaction. So what is going to happen? Hydrogen forms 2H plus 2 electrons. This 2H plus is going to combine with OH minus. Where did the OH minus come from? The OH minus comes from the KOH. And what does it form? It forms H2O. So your KOH is going to become little diluted because water is getting formed here. So hydrogen is coming from this side and KOH is coming from this side. So at this surface, the reaction is going to take place. Oxidation, so this electrode will be negative. Then cathode, what is going to happen? You have 2OH minus, you have H2O plus O2. So the H2O formed is going to permeate this side. Oxygen is going to come from this side because this is porous. It is clear. And 2 electrons. So what is it going to form? It's going to form 4OH minus. So we can realize that the H2O is again getting converted into OH minus. So in the net reaction, if you see, H2 is combining with OH minus to form water. So net reaction will be H2 plus O2 forms H2O. So this is the advantage of fuel cell. What is the advantage? That you are using gases which are non-poisonous. The product formed is also non-poisonous. It's clear. The EMF of this cell is about 1.23 volts. So this has been asked. So EMF of the cell. So this can be what you call MCQ. EMF of fuel cell EMF of fuel cell is 1.23 volt. Please remember these values. Daniel cell 1.1 volt. Okay. Then we have dry cell 1.5 volt, lead accumulator 1.8, fuel cell is 1.23 volt. So these are very essential. Some marks are allotted for giving this. Okay.